Hi, this is Frank Kane, and Jason just spent a lot of time in this section talking about relational databases and different forms of data normalization, how you might use different tables to relate to each other to store data in a very compact and normalized fashion. So let's see those concepts in action here by using Microsoft Access. Now, bear in mind as you're watching this, the exam is not going to test you on your ability to use specific tools. So do not focus on the mechanics of how I create a database, how I create a table, how I tie these tables together. What's important is the concepts, what the different forms of normalization are, and how these tables might relate to each other in a normalized form. Now, I'm just using Access here because it's something that you might have installed on your PC already. In the real world as a data analyst, you'll probably be using different tools than Microsoft Access. But if you do have Access installed on your PC, I invite you to spark it up and follow along with me. It can often be beneficial to go hands-on and practice these concepts yourself. Helps it sink in a little bit more deeply. So if you are following along, go ahead and double-click on the blank database here, and let's create a new database to play with. Let's call it Data Schemas, because that's the name of this section. And let's go to the design view here to design a new table. We'll call this table Ratings Denormalized. So what are we going to store in this thing? So imagine that we have a website like IMDb or Netflix or something like that, some site where people can rate the movies that they've seen in the past. So for example, I might have rated the movie Gone with the Wind 3 stars on a 1 to 5 scale. So what kind of information do we need to store for that? Well, we need the usernames, the person that actually made the rating. We need the name of the movie being rated and the actual rating for that movie, and maybe the time that the rating was made as well. So let's make that real here in this table definition. So we'll start off with a primary key that's already predefined for us, an auto number ID. We need some sort of a primary key for our ratings table. And we will also have a username, which will be text. And then we'll just have one big ratings column here, which in a single cell will contain all of the ratings for that user. So let's make that a long text because that could be a lot of information. And let's also make a timestamp field for the time that the rating was left. We'll make that a date time. All right, so again, we're trying to illustrate first a denormalized form, completely denormalized. Let's actually switch to the datasheet view and type that in. Now we need to save the table first. Fine. So we'll start off with the first row. Imagine that we're talking about myself, Frank Kane. And again, in the ratings field for this denormalized example, we're just going to jam all of my ratings into one cell here. That's what makes this denormalized. So imagine I have some comma-separated list of movie names and ratings that just follow off each other. Let's say Gone with the Wind, comma 3 stars, Star Wars, comma 5 stars. What's a movie I watched last night? It was some old James Bond movie, License to Kill. And honestly, it wasn't that good, 3 stars. And we'll give that a timestamp of right now. And we can type in another one too. Let's say Joe Smith, rated Star Wars. He's not a science fiction fan, maybe 3 stars for that. And Inception, good Christopher Nolan movie, 4 stars. And let's say that he rated that yesterday. All right, so we're not going to really do anything with this table. I'm just sort of illustrating. Make sure we click out of that to make sure it gets saved. Just illustrating what a denormalized form might look like here. So you can see here, I've jammed together all of the movie ratings for a given person into one cell here. So instead of having individual rows for each individual rating, I've combined all the ratings for one person into a single row. And that's what makes this denormalized. Now, obviously, there's a lot of duplicated information here. I had to type out Star Wars twice, and I have to sort of decode that rating cell there on my own. It's not really already broken up into a nice structure with individual columns for movies and ratings. Now, I don't want to make it sound like denormalized data is always a bad thing. It does have its place. Imagine you're building some sort of a system that needs to very quickly retrieve all of the movie ratings for a given user. And furthermore, it wants to very quickly retrieve the human readable name of both the user and the movies themselves. If you were building something like that, this would make a lot of sense because all I need to do is retrieve one row from this database and I can, with one fell swoop, get every rating that this user made in a human displayable form. So denormalized data does have its place, but that's not the point of this section. We're talking about the various normal forms and normalizing your data. So let's step up to the first normal form. Let's first of all close this out. Sure, we can save it. And we'll again create a new table design. And let's do this a little bit differently. So we will again start with an ID, and this can be automatically populated as an auto number. Make that our primary key. And this time, let's add a little bit more structure. So let's have a separate first name and a last name for the user. And now instead of having one big ratings cell, we're going to have individual rows for individual ratings. So if I have more than one rating, I'll have multiple rows in this database for myself that indicate each individual movie rating. So we're talking about a single movie rating now on each row of this database. So to store that, I will need the movie name, as well as the actual rating, and we'll make that a number. You can see already we're adding a little bit more structure to this. It's not just this big old comma-separated string. And again, we'll have a timestamp, which will be a date time. All right, so let's populate that with some sample data. First, we need to save it. Hit the little disk icon there, and we'll call it ratings-1NF for first normal form. And let's switch to the datasheet view and enter in some sample data. So let's say Frank Kane watched License to Kill. And I rated that 3 stars today. And let's also imagine that Frank Kane also rated, what did I watch the night before? The Living Daylights, another James Bond film that was a little bit better, 4 stars for that one. And let's also imagine that Joe Smith watched, Star Wars. And of course, that's 5 stars. It's a classic. Guess it depends which Star Wars, huh? Pick a date for that. All right, so this is an example of the first normal form. Make sure we click outside of that to make sure it gets saved. So here, instead of having all of my ratings on one row, I have multiple rows for each rating. And that's what makes this the first normal form. Now, the problem here that I still have is that there's a lot of duplicated information still, right? So I had to type out the name Frank Kane, and that actually appears twice. It will appear for every single movie that I rate on a new row. Similarly, I typed out the movie name more than one time here as well. So if more than one person rated Star Wars, I would have many rows that have the string Star Wars stored in there. So not only does that introduce the possibility for error in case somebody typed that in an inconsistent manner or had a typo in the movie name, it also stores more data than we need, right? It's just a waste of space. So that's what the second normal form attempts to solve. The main point of a second normal form is to eliminate duplicated data. So instead of typing Frank Kane over and over again or Star Wars over and over again, I'm just going to represent that by some identifier that I can use as a key that ties 2 different tables together. So let's imagine, if you will, that Frank Kane is just user ID 1. I might have another users table that says user ID 1 means Frank Kane, and the text Frank Kane only appears once, only gets stored in that one place in that one table. So let's make that real. First of all, let's save that and close it out. And we're going to create 3 tables this time to illustrate the second normal form. So let's start with our second normal form ratings table. Again, we'll go to create and say table design. And we'll still have some sort of an ID for each rating. We need a primary key of some sort. Make that an auto number and mark that as the primary key. And now for each rating, we're just going to store a user ID. We'll make that a number. And we will have a movie ID. Instead of typing out the full movie name, also a number. And maybe we have the actual rating itself, also a number. And finally, the timestamp of that rating. That will change for each individual rating potentially, so we're going to store that within the ratings table. All right, let's save that table, and we'll call this ratings-2NF for second normal form. Now to use this, we're going to need a user table and a movie table that will allow us to look up the names for each user and the names for each movie. So let's go ahead and create another table design. This will be our users table. So let's call this user ID as the primary key. We'll make that a number to be consistent with the other table. And the user name, maybe first name and last name. We need to mark that first row as the primary key, the user ID, make sure that's unique. And let's save that and call it users. And we'll do the same thing for movies. Let's create a new table design for movies, and that will have a movie ID, which is a number. Important that that's a consistent type with the table that you're tying it into. Make that our primary key, and we'll have the title of the movie, which will be text. All right, and let's save that and call it movies. All right, so to recap, we have our second normal form of the ratings table here that just has user IDs and movie IDs instead of full names. Again, we have separate rows for each individual rating, and we're still storing the rating and timestamp on each row of this table because that could vary for every unique rating. That user ID ties to the users table using the user ID field, so that will be our key that ties them together. In the context of the ratings table, the user ID is the foreign key to the users table. And that's how we'll look up the actual name for a given user ID if we need to display it. Same idea for the movies. So on the ratings table, we have a movie ID. That key ties to the movie ID in our movies table, which allows us to look up the title for each movie. All right, cool. Let's close these out and tie them together with relationships. So let's start with our ratings 2 and F table here, and let's switch to the design view and go to table design. From here, we can click on relationships and figure out how we're going to tie all these together. So let's drag that ratings 2 and F table out here, and also our users table and our movies table. Cool. All right, so first we need to close out that ratings 2 and F tab here. Otherwise, we can't actually edit these things. So we're going to tie the user ID in the ratings table to the user ID in the users table. Now note this is a one-to-many relationship. So for every one user ID, that can relate to many ratings. One user can create many ratings, so that's one-to-many. And I'm also going to click the Enforce Referential Integrity option here. That will allow us to actually validate that I'm entering a valid user ID in the ratings table as I enter data. So that will force it to check that the user IDs I'm entering actually exist in the user table before I try to save a given row. Let's hit create. And we'll do the same thing for movie ID. We'll drag movie ID from ratings to movie ID in movies. Again, this is a one-to-many relationship. So for every one movie, that could tie to many different ratings. A lot of different people can rate the same movie. And again, I'll enforce referential integrity to make sure that we do not enter any invalid movie IDs as we're creating new ratings. Create that. All right, let's hit the save icon. And let's enter some data and actually see if this works. So let's just double click on ratings 2 and F and enter some stuff. So the ID is actually the primary key for the rating itself. We'll let that populate automatically. Now I don't have any valid user IDs yet or movie IDs, so I have to start there, right? What do I enter here? I don't have any users or ratings yet. So let's first go to the users table. And let's say user ID 1 is Frank Kane, and user ID 2 is Joe Smith. And I had to tab to this next row here just to make sure that second row got saved. Same thing for movies. Let's double click that. And let's say movie ID 1 is Gone with the Wind. And movie ID 2 is Star Wars. All right, so now we have 2 users and 2 movies in the system. Let's enter some ratings. Back to ratings 2 and F. Let's say the user ID 1, which was me, rated movie ID 1 3 stars. And I did that right now. And user ID 2, which was Joe Smith, right? Rated movie ID 2 4 stars. And I don't know, he did that a couple weeks ago. All right, so far so good, right? So this is a much more compact way of storing those movie ratings. Instead of spelling out the usernames and movie names, I'm just referring to their IDs off in the separate user table and the separate movie table. So this is an example of the second normal form. We're not duplicating any data here. That's the key. Let's see that referential integrity option in action. Let's say that I try to enter user ID 40, moving movie ID 241, 3 stars. What happens if I try to save that? Oh, I cannot add or change a record because a related record is required in table users. So that is saying, hey, user ID 40 does not exist in my users table. You defined a relationship between these 2 fields. This is a key to another table, and it's not valid. It points to nothing. So it's not going to let me do that. So that's another good benefit of relational design. You can sort of enforce those sorts of rules there and make sure that you're actually pointing to valid user or movie data, whatever it is that is in your separate relational tables. All right, so there you have it. Data normalization in action and the fundamentals of relational databases. Hope that was useful for you. Go ahead and close out of Access if you're done with it for now, and let's move on to our next topic.